Hello guys, it's your guy Fiera. Welcome back to my new tutorial. In this tutorial we are going to be generating the M&J codes required for VMS project 10. The programming has already been done, so we are going to go through each of these operations, beginning with the Chamfer definition. We are using a TITAN-86L as CNC controller coordinate system. We got Mark 1 and Mark 2. So Mark 1 is actually at the main spindle and Mark 2 is at the back spindle. Stock definition. Of course, adding some extra material of 0.2 for the facing at the main spindle and equally some extra material required for clamping. We go for the green check. Target. As our target, we are taking the 3D model. Go for the green check. So, looking upon the setup, edit setup, machine preview, by selecting main spindle. Now, we are at the main spindle. So currently the jaw is properly seated. I like this position. In case your jaw is not properly seated, you want to make sure that you actually highlight this Z-axis. By using the mouse wheel, you just want to move it up and down in order to get the correct location of your jaw. So I'm just pretty good with this. Going to the back spindle, select in stock such that the part is going to leave the main spindle and go to the back spindle. Now, going to the back spindle, you just want to highlight Z and move it upward, downward until the jaw actually sits on the part correctly. So I'm pretty good with this. Now, currently the part is in the sub spindle. I do not want to start my operations with the back spindle, so I will just come back under main spindle, making sure that stock should be selected over here, and I go for the green check. Looking at the operation, starting with facing operation for the main spindle, edit operation, show geometry. So we are always selecting this line or this face. Tool. I am using an external cutting tool of angle 35 degrees for my facing. Levels, always safety distance. Technology, I am using a roughing pass and a finishing pass. Looking at the simulation. So the next operation we want to make is turning operation. Edit, geometry, show. So we are actually turning from the chamfer to the other end of the part. So we are turning the whole part. Tool. I am equally using an external cutting tool, but this time around of 60 degrees. Go for the green check. Technology. I'm using a roughing pass with a surface finish and a strategy of non-descending. Go for the simulation. Now, the next operation is about this groove over here. Groove operation. Show geometry. For the groove, we begin from this point to this point. As tool, I'm using a groove tool. Levels or fine technology. Roughing pass and equally a finishing pass. Looking at the simulation. Grooving operation done. As next operation, we are going to be making drilling operation for this portion. Now, looking upon our hole, we got a hole of 0.56 inch. So we are going to be using a drilling tool of 0.5 inch. The 0.6 inch remaining, we are going to be using a boring tool in order to make a proper hole finishing. Looking at the drilling operation, coordinate system, we have no coordinate system. Remember that when we are dealing with turning operation or milling operation, we do not define coordinate system for holes because the hole is already at the center. Tool selection, we are using a spark drill of diameter 0.5 inch. Levels, no level. Technology, starting point. Starting point should be this and the drilling end should be this, all through the path with the delta value of minus 0.2. Oh, fine. Looking at the simulation, for this rest material, we are actually going to be using boring operation. Looking at the geometry, we actually select the inner hole, this line, tool. We use a boring tool. The boring tool in this case is simply an internal turning tool. Go for the green check, levels, fine, technology. You want to make sure that with mode, you are actually using long internal, roughing pass, and of course a finishing pass with compensation on. Strategy, non-descending. Go for the simulation. So we got this chamfer. If you see, this has not been machined, so we got this chamfer to machine, and now we equally got this hole. I'll be doing this hole when I'll be working with the back spindle. Go for chamfer operation, geometry, show geometry. So we got this edge as our geometry. Tool, the same boring tool, levels, or fine, technology, descending should be activated, a roughing pass and a finishing pass. Go for the simulation, chamfer done. At this timing point, we are actually done with all our operations on the main spindle. In order to work with the sub spindle, we have to make a path transfer from the main spindle to the sub spindle. Looking at our MCO, edit, machine preview. Looking at the operations in the MCO, first operation, we have the rotatory. This rotatory is actually our sub 2 turret. Since our aim is actually to move the sub spindle to the main spindle, the sub 2 turret and the main 2 turret is out of the way to avoid any collision. Looking upon the rotatory movement, so the sub 2 turret back to home position. Next operation, movement. We are actually telling the sub 2 turret to move out of the way. For this, you just have to come under Z and move it all through with your mouse. Move this way and notice that the most safety position is 0. So when you are done identify that, you just come under paste ax value and you insert. Now, this is actually the main 2 turret. So you equally want to move the main 2 turret out of the way. Movement. Now, by taking a rotation value of either 90, so you just come under this one, B. The rotation value can either be 0, 90, or equally minus 90. So currently, when I take a rotation of 90, you notice that the two will actually make a collision with the incoming sub spindle. So 0 is actually the right direction for this, and you just insert paste. The main spindle. So path transfer, since the main spindle is actually holding the workpiece, we do not use a movement but rather a path transfer. Path transfer, home position. So I am just telling the main spindle to go to home position. Back spindle, movement, home position. Then I have to tell the back spindle to move closer to my main spindle. So this is Z. Looking at Z over here. So as you notice, just with the VMS, I can actually move it within the distance I wish. So it should not be touching the main spindle. This is wrong. You have to go a little bit backward. This is fine. And then paste ax value. Okay, fine. Next thing you want to do is you have to come downward and select stock lock. Look what happens. The main spindle locks on the path. Then for the next operation, clamping, you want to select close on stock. This means that the sub spindle closes and the main spindle opens. We are done with this. You just want to drag and add this new operation. Since the back spindle is currently holding the workpiece or the path, you do not use movement but rather you use path transfer. So we simply tell the back spindle to go back to home position. At this timing point, you just want to save, calculate. So with this, we are done with the MCO. We can now perform all the operations required on the sub spindle. Looking upon our back spindle operations, first operation facing, geometry. So we are taking this line or simply this face. Tool, I am using an external cutting tool of angle 35 degrees. Now, making sure that you are not working with this direction but rather with this back side. Levels of fine technology, roughing pass and a finishing pass. Looking at the simulation. Facing operation done. Now, for our next operation, we want actually to make this chamfer at this edge and then complete this cut out of this hole. Edit, geometry, show geometry. The chamfer edge is our geometry. Tool. For our tool, we are actually using the same internal turning tool or the same boring tool, making sure that you are taking this direction as your cutting direction. Technology, long internal should be selected, strategy, descending. Roughing parts activated and surface finishing. Looking at the simulation, chamfer done. Looking at this, using turning operation, geometry, show geometry, and the exact geometry we are taking is this cut out or simply this line. Tool, we are using a grooving tool, a very small groove tool. Looking at the groove parameter, we got a groove tool of A, this is A, 0.0157, and a groove width of 0.0039. Go for the OK. Levels, technology, long internal, with a roughing pass and with a finishing pass with compensation on. Strategy, link. Now, I will just select none as for now and save calculate. Simulate. Okay, so you see what happens. It actually machined the part we want, but since the tool is going back to home position, it machined an extra part or unwanted part we do not want to machine. Now, in order to resolve this, you have to use this link, taking normal, save calculate. So rather of returning back to home position in a straight line, it actually follows the path of a curve. So this is the use of a link. The link actually makes the tool to follow the path of a curve when it is returning back to home position. All operation has been done on the main spindle, a part transfer has been done, and all the operation has been done on the sub spindle. So we actually have to synchronize the main spindle and the back spindle. For this, you want to make sure that you select operations, come under China synchronization, and simply save. Looking at the full simulation operation, simulate, solid verify. Rest material. All fine, project totally done. With this, we are done with VMS project 10. If you have any question regarding this project, do well to contact us by Facebook or by email, or even leaving a comment in the commenting box. In the next tutorial, we are going to be generating the M&G code required for VMS project 11. Keep liking the video, keep sharing, keep commenting. Thanks a lot guys. See you guys in the next tutorial.